kind of go back a little bit in the history, right? We pretty much had a voice as a service. It was circuit switch voice. So it was more a symmetric 2G traffic. In addition to voice, it was low speed data with 3G for texting. So with LTE now, you have video streaming, internet browsing. Basically, it's gone in a increase in a significant way in terms of the required bandwidth throughputs. And thanks to high throughput satellites with LTE, mobile network operators who have obligations to provide connectivity where there is no terrestrial coverage, they're able to use the high throughput satellites to bring in high data rates in to a remote site. What it means is going from previous generations of radio access network technology to LTE with all these various applications. It means that there has to be capability to have a quality of service handling. You have to have, if you take a look at your cell phone, anytime anybody is on that cell phone, in the background there are many apps that are open, which means there are tens of TCP connections that come from a single handheld, which means now you look at a site with a base station and people connecting to that translates to thousands of TCP connections that would need to be handled from a single site over that satellite link. Other things, clearly, while you have high throughput satellites, bandwidth is still a premium. So, you need to be able to look at a satellite link and see how do we optimize that. So we have capabilities as we moved into LTE to do what is called traffic acceleration. This is where we look at, if you look at LTE, it has got what is called S1 interface and GPRS tunneling protocol. So we actually look into the tunnels, we meaning the satellite network, compress headers, determine what type of traffic it is, apply right quality of service, and in effect, provide better user experience and have a satellite bandwidth savings. So, all this really moving to LTE has led operators to upgrading their network infrastructure with more sophisticated provisioning and orchestration, quality of service management, and for the different applications, and more software-defined solutions, virtualization of network functions, making things more scalable as they need to grow. Now the networks can do that. So that's the gist of it. Look, I think the first important thing MNOs look at are what are called the key performance indicators, or KPIs, that need to be met. These include, data rates to a given site, latency, availability, things like packet error, and many other KPIs. So this is a big requirement. The other thing that is really important, a lot of these mobile network operators, the majority of the sites they have are terrestrial. And where they're putting in satellite backhaul, because terrestrial can't support it, they don't want, from an operations point of view, to have a complete different way of doing it. So they want to try to minimize the differences in operations, whether it's a satellite based backhaul connection or terrestrial. So as an example, if their architecture is layer 2 based for terrestrial, that's what they would like for satellite as well. Or it could be layer 3, in which case they want layer 3 for satellite too. So it's really important for them that from an operations point of view, the overhead is minimized by keeping both of these as similar as possible. Now, for satellite alone, there are multiple things they also look for. Obviously, bandwidth is very expensive. So, how do we manage the bandwidth? So we have, especially in the return direction, schemes to support where bandwidth is shared at different sites, because the traffic may be bursty, and when one site is not using it, the other site may be using it. Or if the bandwidth is, or if the traffic is more predictable, they would like to have what are called SCPC type links, where you kind of fix allocate bandwidth to one site for efficiency. There are also capabilities now we have developed that can dynamically switch a terminal from being in a shared pool to being dedicated. So this is, I would say, another important thing is efficient use of bandwidth and being able to do both fixed and shared type solutions. Other things are typically at a remote site, they also have, when they transition, say, from 2G, 3G to LTE or coming up to 5G, it's not, a lot of times it is going to be multiple radio access network technologies behind the satellite terminal. So you have to simultaneously support multiple networks behind the satellite. So they want capability to carry individual network traffic through the satellite backhaul and be able to have its own quality of service. So that is important. And other capabilities they're also looking for when they deploy, if a satellite terminal can support, for example, what is called precision time protocol to bring in timing connectivity to small base stations. So that's another capability that we have seen. So yeah, these are really some of the important ones that the mobile network operators look at in terms of technology and the requirements. So first off, a lot of the MNOs, they are reluctant to go into rural areas. They rather, a lot of their revenues are where people are, and urban, suburban, and those are really the areas they want to really put all their sites at. But they do have obligations to go, government obligations to go cover rural areas, especially, think about the 5G spectrum auctions that are going on for these MNOs to deploy 5G in urban areas. They need to provide LTE type services in the remote areas. So we are looking at solutions where, we can tell the MNOs, hey, we can deploy remote site community-based solutions, and these are community broadband solutions. So, for example, we can put in our own very cost-efficient, cost-optimized cellular solution at these remote sites and partner with the MNOs so that they don't have to manage these type of networks, and they just basically would leave all of that up to the satellite service provider to manage. And in return, they would have to provide the LTE spectrum for this in these remote sites. So this is one area. Other is we've also seen in these where MNOs are not obligated to go, we do have similar type of solution as a private LTE network, or it could be, community broadband via community Wi-Fi type solutions where you go into these remote areas and people can't afford, monthly subscriptions, but they can pay for, prepaid data packs that could be hourly, could be daily, or and so on. So affordability, collectively, a lot of people buying these kind of data packs makes a business case for us. So this is another opportunity. I would say, furthermore, in these remote areas, you're seeing now a lot of solutions that provide value-added services to the communities. These could be like telehealth, e-governance, maybe if it's a farming area, precision farming, and so on. So this is, using technologies like mobile edge computing and so on. We can leverage on satellites' capability to get to these sites, and on top, provide these value-added services. In addition to all of this, I would say, don't rule out urban areas for satellites. There's also a role to play there. And some of the opportunities would be backing up terrestrial networks in case of disasters. So with the SD-WAN type solutions, you can have a backup of terrestrial, could be a satellite backhaul, or it could be even more intelligently routing traffic where, if you have delay sensitive traffic, it can go on a terrestrial connection, and delay insensitive traffic can go on a satellite connection. So this is another area that we believe that we have opportunity from a satellite service provider to augment the terrestrial networks. Of course, mobility, with respect to areas that are not covered by terrestrial gaps in coverage, that's another area that I think that both aeronautical, maritime, land mobile, these would be other opportunities. Clearly, satellite backhaul has many distinct advantages, which makes it very indispensable, for options for telecom service providers to really expand their networks. So as I spoke before, these MNOs have obligations. They'll continue to have these obligations to reach remote areas. Satellite is the best solution for those types of locations. And again, in terms of whether it's on land, sea, you're talking about cruise ships, private ships, oil rigs, places that you cannot reach with terrestrial solution. There's a clear business case for satellites that will continue on. I think one of the other ones I spoke about already is providing resiliency for terrestrial networks that will be there. And as we see 5G coming, I think the 5G ecosystem and 5G is really network of networks, and the satellite segment will certainly complement the terrestrial segment. So you're going to see an explosion of new types of applications, some of which I already spoke about in terms of these mobile edge computing and reaching remote areas. It could be even in industrial locations, factories with IoT, things that you really can offload from terrestrial networks into locations that really satellite is primed to cover. So I think all the areas I've mentioned really would put in the next 5 years satellite solutions in complement the terrestrial networks.